Okay, I blew up my laboratory power supply. Um, I was charging a whole bunch of batteries, and I overloaded it. And I'll show you what I did. Here. What happened was, I took it apart, and it has a rectifier where you have your AC in on these two corners, to the plus and minus. That pretty much it turns it from AC into a pulsating DC. And there's a guy on. If you want to know more about these, they're called either a wheatstone bridge or a bridge rectifier. Pretty much, it's just 4 diodes soldered together, and that's pretty much all they are. Pretty simple. And what happened was, it's been getting so hot that it melted that wire right here. And what happened was, a wire touched the other pin and created a happy little short that filled my room up with smoke. So either I blew a diode in that rectifier here, or or it just gets so hot that it's just melted the insulation off that wire and caused issues. So, and that one's rather small, so I'm going to replace it with one that's like twice the size. And I yanked this one out of a power supply, you know, those computer battery backup system things, but this is out of one from a server, so it should be much better and handle a lot more current, since I think this one was on a 220 circuit. So I think it was like 15 amps at 220 volts. And this one here has little teeny tiny little dinky little thin wires, so I know it's maybe carrying 1 amp at most, or 2 amps at most. So I'm just hoping there was no other damage from that. And the thing is, this thing right here screws to the back of this heatsink right there in that little square cutout. So I'm probably gonna fit this one roughly over there and put a zip tie around it or something. And this thing's so big, I don't even know if this thing will even get warm. But yeah, I checked all the transistors here; they're all fine, and everything else here on the circuit board looks fine. Transformers outputting perfect, but I have to bypass the silly majigger thingy here. So, and I'm gonna put this in, and I can't go wrong because it has the 2 AC lines. I just match those up to the AC ones in the middle, and the plus and the minus, I just match them up to the wire, and I'm good to go. I can't go wrong, right? Just do one at a time. And then I just got to reassemble this, and it should be a happy little power supply again. And you know, it's the one I like, with triple output. Terrible lighting in here. But yeah, it's just a simple basic laboratory power supply I got. I think I paid $4 for it at a garage sale, and it's perfect. So, and so anyways, I'm gonna pause it, and then I'm going to hopefully hopefully have it working, and I can show you. Okay, here's a better shot of it. It changed the angle and the lighting and everything. And you can see how it shorted out to right here on the other pin, and it fused the wires together. So yeah, that thing's toast. And I fixed the new one right there, or the repurposed old one right here. So I guess that's where I'm gonna put it. And then so I'm gonna heating up my soldering iron right now. So it's just wanted to show. That's what happens when they were wired together like that and they had a zip tie, and then it just got hot, and then eventually it melted right through the insulation. So this time I'm not going to zip tie it. I'm just going to let it do its thing, and it should be much better. Okay, so here's my my ghetto soldering job. But it should work, I hope, I guess. And one thing I wanted to show you here was let me get it. Here we go. Here's the old one. Look at that. Whoa, that thing got hot. I don't trust this. It may still work, I don't know, but I'm not gonna dare trust it again. Because even if it works, it's proven that it's inadequate for this power supply. It's not supposed to run that hot naturally, ever. You know, so if that's the case, that's a failure of the manufacturer to allow this part to run that hot. So, so I'm putting one in like 4 or 5 times rated. So this should be fine. I just got to reassemble all these, and one oh, did I lose them? I hope not. When you work with these kind that have those funny round transistors, there's all these little isolation bushing things that, here they are. They're like little these things right here. You get a million of these, and you have to put these bushings back on, and otherwise they will conduct with the heatsink, and the heatsink is grounded. So it happens that you ground all your transistors, and then they all explode. So, and we don't want that. So we've got to make sure we isolate this and put all those little spacers back in. But let's see what happens. Let's see if I miss one. Okay, so I got it mostly back together. And another thing is my fuse blew. I wasn't paying attention, and it's blown. So I have to find a way of bypassing that for right now, because I don't have a replacement fuse at the moment. So let me get some alligator clips, and I'll bypass that. So I've sorry, I've bypassed the fuse. You never want to do this ever. And when I mean ever, I mean ever. So no smoke, no explosions, nothing. Whew. I don't smell any smoke. Let me get an LED. Okay, so I got a LED strip lighting thingy here, and I just have yellow cables. So I'm gonna have to use yellow for positive and yellow for negative. So I'm gonna point this away so we don't blind you guys. So the red one, this one, let's put here. And this is the ground. So I am on output B. So I put this to B. Turn this on. So I go to voltage on B here. Whoa. So my LED lights are coming on. So these should be around 12 volts. Huh, my voltage isn't going up. Oh, I probably need to turn up my current. Turn my current all the way up, and that should let me go. There we go. Close enough. She's working. The LEDs are lit. It's not pushing enough current. They should be pushing about 2 amps. So that's good enough for this, huh? So, not bad. Any more current? No. Now they're dimming. Well, they're barely on. So yeah, it's working. I'm all happy. Let's turn that all the way down. Now let's, let's Let's see if the other output here is working too. There we go. Switch this to A so I can see what's on A. And then turn the current all the way up. And then the voltage went up. There we go. Now the LEDs are lit. Yay! All happy. And the best part is there's no smoke. So, yeah, when components turn into that magic smoke, the components don't work anymore. So, I gotta get a fuse because that looks dangerous. That's smoke potential. So, yeah, it's working, so I'm all happy. Yay, I don't have to buy a new one. So, yay, I fixed my, my precision triple output power supply. So, I'm all happy.